Good morning, guys. So we're down the home stretch. This will be the last big topic we use, and then there's going to be 4 lessons over this topic, and then we're done. And you guys will take the last talks test and be done with class. It's kind of crazy that we're almost there. So today's stuff is matrices. We're going to talk about how to write a matrix. So if they say the order of the matrix, they want you to do the rows by the columns. So I have 1, 2, 2 rows by 1, 2, 3 columns. So that's what the order is. However many rows by however many columns. They want you to find a specific value. They're going to give you the row first and then the column second. So I'm going to go to row 1, column 3. My number is going to be 1. Next one, I want to go to row 21, or row 2, column 1. My number is going to be 5. So it's always row by column. Augmented matrix means you're going to write it into a specific form. So we're going to solve linear systems, which is what we've been doing. But now we're going to use matrices to do it. So write an augmented matrix. Here's what you do. You just worry about the coefficient in front. But first off, you want to make sure your equations are in x, y equals a numbers form, or x, y, z equals a numbers, just depending on the problem. So this one, they're already in that form. So I'm just going to take the coefficient. So the top equation is going to be 3, -7. Your equal sign is a line through it, and then -4, and then you make your big bracket to end your matrix. You do the same thing on the bottom. -1, 4, I already got my equal sign, and then 9. So now I'm going to give you one that's a little bit harder. I would rewrite the equations first to make sure that they're in the correct form, x, y, z, and then a number. So 2 divided by 2 gives me 1x. -6 divided by 2 gives me -3y. I'm going to add the z over. I'm going to set it equal to 3. Next equation, it's not in the right form, so I'm going to rearrange it. -x plus 5y plus z equals 12. And then the last equation, I need to subtract my 2z over and add my 2 back over to the other side. So x plus 3y minus 2z equals a positive 2. Now you can write your augmented matrix. My first column is going to be 1, -1, 1. Next column is going to be -3, 5, 3. Next column is going to be 1, 1, -2, equal sign, 3, 12, 2. And you're in your augmented matrix. So that's what an augmented matrix is. So the first problem I want you guys to do as homework be this one right here. This will be good practice. Write the augmented matrix for that linear system. There's going to be 3 problems that you guys are going to submit to classroom. This is the first one. Okay, next thing. Use an elimination, Gaussian elimination, to solve the problems. We're going to rewrite this system back into a linear system. So it's going to be 1x plus 2y minus 2z equals 11. 0x, 1y minus 1z equals 3, and the bottom is just going to be z equals -1. So I already know what z is, so I'm going to plug it into the other equation to solve for y. Y is 2, and you're going to plug that in to solve for x. And you have your answer. 5, 2, -1. So we can always convert this back to a system and solve it using elimination or substitution. It's just whatever you feel comfortable doing. We are going to use elementary operations to solve the problem. So this one, if you see a double arrow, that means just switch the rows. So I'm going to take row 2 and move it up to row 1. So now row 2 is going to go here in row 1 spot, and row 1 is going to go below it. So that's what that operation means. If you see a number out front of the row, that means you're going to multiply just that row by that number. So I'm multiplying just row 1 by 1/4, aka you're dividing by 4. So 1, -3, 2. The second row, they didn't do anything to it, so it stays the same. If you see something like this, you're going to multiply the first row and then add the second one. However, whatever you're multiplying, whatever one comes first, so row 1 comes first, is going to stay the same. So I'm going to go ahead and write it again because it's not going to change. Now I'm going to multiply it by -2. So I'm going to get -2, +4, +10, and I'm going to add it to row 2 to change row 2. So I'm going to get 0, 7, 11. And then lastly, you're going to use row 2 plus row 1. So row 2 is going to stay the same. I'm going to add it to row 1. And there you go. Our goal on this, guys, so row echelon form is what we're after. What you want is in the top left, you want a 1 on your augmented matrix, and then everything below it needs to be a 0. And the next one, the 1's going to drop down 1 and to the right. It's going to keep going, and that will go on forever. And the rest of it should be zeros, and then you're going to have your equal sign, and it could be whatever number. And the reason why we do that is because this is like saying x equals 2, y equals 13, z equals 16. So we're going to use these elementary row operations to solve these equations. However, if you don't feel comfortable, you can always use elimination or substitution. So this first one, I went ahead and wrote it into the augmented matrix, and here's what I would do. So I want my top left number to be a 1. So I'm going to multiply 1/4 times row 1, aka I'm going to divide by 4. So I'm going to get 1, -2, -19. Row 2 did not change, so it's going to stay the same. Now, in row 2, I want this to be a 1, because I need to drop down 1 to the right. So I'm going to multiply row 2 by 1/6. Row 1 did not change. Row 2 now looks like this. Now here's where you're going to have to do some different things. Everything else on this left-hand side of the equal sign, besides these two, needs to be a 0. So how am I going to make this a 0 and this a 0? Well, the first one I'm going to do is I'm going to add, row 1 is going to stay the same to row 2. So whichever one comes first stays the same. Now I'm going to add it to row 2. 1 plus a -1 makes it a 0. -2 plus 1 would be -1. -19 plus 11 would be -8. Okay, the next thing I'm going to do, how am I going to make this a 0 now? Well, I need to multiply, I'm going to need to change this number. So I'm going to multiply it by -2 and add it to row 1. So row 2 is going to stay the same because we're not changing it. Now, if I multiply row 2 by -2 and add it, that's going to still be a 1. This is going to be a 0 now. I'm going to get 16 plus -19 would be -3. And then we're almost done. I need it to be a positive 1. So I'm going to multiply row 2 by -1. Guys, there are a bunch of different routes to do this. There's not one correct way. But now you have your answer. The top one is saying my x came first in my first column, so I'm going to get -3. My y came second, so I'm going to get 8. So your answer to the system would be -3, 8. If you used elimination or substitution, you would get the same thing. If they throw 3 variables at you, it's very similar. You're going to have an x, a y, and a z column. In this one, my x is 1, my y is 4, my z is 0. Next one, I have 0 x's, 1 y, -6z, -9, and then -4, -5, 1, and -17. The nice thing about this is like your diagonal is already a 1. So we want to try and keep it that way if we can. However, you're going to have to do some different things. So I need everything below this one to be a 0. So in this column, I need everything to be a 0 besides the one in the top left. To do that, I'm going to multiply row 1 by 4 and add it to row 3. So row 1 is going to stay the same because that's the one you're changing. Row 2 we didn't do anything to, so it's going to stay the same as well. And then now I'm going to multiply row 1 by 4 and add to row 3. So it's going to be 0, 11, 1, and then 35. We keep going. So now we have all my zeros. We're good there. Now I want to see, can I change these two to a 0 because I need the 1 in the middle. To do that, I'm going to multiply row 2 by -4 and add it to row 1 because that will give me a 0 there. So row 2 is going to stay the same. Row 3 is going to stay the same because we didn't do anything to it. Now we're going to multiply row 2 by -4 and add it to row 1. So I'm going to get 1, 0, 24, 49. Next step, I'm going to go over here. We're going to multiply row 2 by -11 and add it to row 3 so we can get a 0 there. So 1, 0, 24, 49, it's going to stay the same. 0, 1, -6, -9. 0, 0, 1. Sorry, that's going to be 67 now, and then 134. So now you got some really big numbers in row 3. What you want to see is, can you divide it by something to get a 1 there? You can. You can divide it by 67 because 67 goes into 134 as well. 0, 1. This should be 2. So now you know what your z is. Your z is 2. So the next thing we're going to do is we're going to multiply row 3 by negative 24 and add it to row 1 to get rid of the top number up there. So it's going to be 1, 0, 0. It ends up being a 1 right here. Row 2 did not change. Row 3 is going to stay the same. Thank you guys. There's a bunch of different ways to do this. And then lastly, my last step, I'm going to take row 3 times 6 and add it to row 2. So now you see how you have your augmented matrix that's all 1s, which is what you want. The rest should be 0 on the left-hand side. This is saying x equals 1, y equals 3, z equals 2. So I'm going to get 1, 3, 2 is my answer. Okay, so what I want you guys to do is I want you to do this one as your number 2 problem, this one as your number 3 problem, and submit those to Classroom. Just as some extra practice. And then I will do a short YouTube video for Hawks as well. If you have any questions, please let me know.